like that. I will get everything. So everything here it will see arrived time I will get, and disconnected also everything I will get here. If I click here, what happened when you have arrived and when you have last seen, everything it will be visible for me. So don't say after that I have there at the class. Don't message like that here. It will be display here. Right. We'll continue this one. Now, what is the classification based on SPDF block elements? Now, what is this classification? Here, actually, this is based on actually the last electron, how it enters here. Last electron means what actually? Differentiating electron. Differentiating electron, generally called as, isn't it? Generally called as last electron. So for example, if the last electron enters in the ns orbital, that is called what? S block element. If the last electron enters in np orbital, then it is called what? P block element. That means if the last electron enters in the valency shell of s orbital, valency shell of p orbital, they are called s and p block elements. Now what is d block element? The last electron, differentiating electron, is entering in the n-1 d orbital, inner shell of d orbital, isn't it? That is called what? D block element. What is a block element? The last electron is entering in the n-2 f orbital, isn't it? These are also what? Inner shell, isn't it? So let me see that from everything, each and everything now. Now, first of all, S block. S block carries what? First A and what? Second A. Second A. So S block carries which group elements? Tell me. S block carries elements? S block carries which group elements now?
So first and second.
All of you have to respond.
First and second.
First A and second A. Now S block carries two group elements. They are first A, second A. Otherwise, first group and second group elements. Simply you can say first group and second group carries in S block. Next, P block. P block will carry what? Actually, 13th group, 14th group, 15th group, 16th group, 17th group, and 18th group. Otherwise, in the Mendeleev periodic table, according to that one, in the Roman letters, if you write what happened, this will be third A. This will be fourth A. This will be fifth A. This will be sixth A. This will be seventh A. And this one will be eighth A. Or zero group also we can call this one. Now, in S block, there are two groups are there. In the P block, there are how many groups are there in the P block? How many groups are there?
6.
6 groups are there from 13 to 18, isn't it? Now, I told you already, you have to remember. What to remember? See, in for examination, no, remembering all these elements is difficult, quite difficult. 118 elements is very difficult. Recently, if one of the, student, I think around first class, I think from Belgaum only, he got something Indian, just like Guinness record book, he got something Indian record book by remembering all the 118 elements. At the time, at the age of what? Only what? First class, I think. So he got some prize also, something. He got something what? Indian record book. What is actually main thing he had done? He actually practiced all 118 elements. So if you ask the atomic number, he will say the atom name. Atom name, that means element name. If you ask element, if you say element name, he will say the atomic number. So because of this small knowledge only, he got something, he entered into what? Indian record book actually. So a child who is actually studying first class, if you know everything about the elements, you are studying what? 11th class. So you should know at least what happened up to 30, atomic number up to 30, isn't it? Atomic number up to 30, and as well as what happened, you should know first period, second period, third period, fourth period elements. Okay. So all these comes under where in 30 only. Okay, first period, second period, third period, fourth period, they comes under 30 only. So what I mean to say is that you have to remember 1 to 30 elements and which period they belongs to and which group they belongs to. Otherwise, what is the reason behind this one? They are asking some questions. They send something what happened, atomic number 25. They ask which group element it is, give the group number and period number. Such type of questions you may get here as a 1 mark question. So that is the reason what happened. All of you remember up to 30, isn't it? So that is very, very important. So this is about the pre. Now where you are placing S block at the left side of the periodic table and the right side of the periodic table, you're having P block element. Now why you are calling these are P block elements? Anybody say why you are calling these are P block elements?
So because in the valency electron P,
their valency electron is entering in which orbital? NP orbital. Remember NP orbital. Okay, right. Now we move to what D block element. Hydrogen does not belongs to any block. Leave it that one. Hydrogen do not belongs to any block. It belongs to periodic table, but does not belongs to any type of block. Leave it that one. Here also you can place in S block, no problem. But what they done actually until now, the position of hydrogen is still uncertain. They put that hydrogen at the middle of what actually periodic table. Leave it that. Now D block elements in which actually differentiating electron will enter in n-1 d orbital. N-1 d orbital. For example, I will explain this one. Now, do you know calcium outermost configuration? Anybody? Calcium outermost configuration? Anybody?
4s2.
4s2, sir. Very good, very good. 4s2 configuration. Now, n is equal to what here? 4, right? N is equal to 4. Now, what is the value of n-1? What is the value of n-1?
3.
3, right? Now after the calcium, next element, same period only, the element is called scandium. Now, configuration of scandium, if you observe, that is what 3d1. Now, differentiating electron is entering in which orbital? N-1 d orbital, right? N-1 d orbital. Why? Because n is equal to here actually 4. Because it's the 4th period, right? Scandium belongs to which group? Which period actually? 4th period. Then n is equal to what actually here? 4 actually. But the differentiating electron, last electron not entering in the 4th orbit, entering in n-1, 3rd orbit it is entering. So whatever the elements, in whichever the elements, isn't it? If electron enters in n-1 d orbital, inner d orbital, isn't it? Other transition elements also we can call this one. That will later we discuss that one. So inner d orbital, they comes under actually d block elements. Now, how many elements are there in the d block? 40 elements are there. Total what happened? 40 elements are there here. Now, these d block elements are placed between S block and P block actually, right? Next, finally, we'll see the F block elements here. You see the F block elements, what happened? In this case, the differentiating electron will enter in n-2 F orbital, n-2 F orbital, isn't it? What is this n-2 F orbital? I will see. I will explain this one. Now, anybody, which period lanthanide belongs to? Which period lanthanide belongs to? Which period it is? 6th period, right? Now, n is equal to here what? 6. Now, n-2 is equal to what? Tell me. N-2 is equal to what?
4, sir.
Now, in the lanthanides, which orbital will fill all from cerium to what here? Lutetium. Which orbitals are filled here? 4f orbitals are filled here. Okay. So what I'm saying here, the elements in which differentiating electron will enter in n-2. Don't write f orbital. You will get half of the marks on. You write n-2 f orbital. Okay. You write n-2 f orbital. In the case of actinides, if you observe here, in the case of actinides, this belongs to which period? 7th period, right? This belongs to 7th period. Now, n is equal to here for this one 7, right? Now, n-2 is equal to 5. Now, for actinides, which orbital will be filled here? 5f orbital will be filled here. So, what I mean to say is that only definition, because in examination, they are asking the definitions and electronic configurations. So, definition is very simple, right? Electronic configuration, how to write here? For example, I'm writing here electronic configuration, how to write, I will explain this one. And where the F block elements will be placed at the bottom of the periodic table. Okay, the F block elements are placed at the bottom of the periodic table. Now, what I'm writing here, see, what is the general electronic configuration? You have to write, because this is not there, you have to write this one. You know, write in the notebook, general electronic configuration. In examination, they may ask this type of things. General electronic configurations of S block. Anybody? S block general electronic configuration, just now I told you. Anybody? Try this. This is small letter. This will be always small letter only. Now, tell me. NS 1 to NS2. This is a general electronic configuration, right? Now, what about P block? P block general configuration will be, anybody? NS2, NP, NP1 to, right, to, tell me, speak out.
NP6.
NP6, very good. That means whichever elements present in the P block, they will have general configuration, may have NS2 NP1, NS2 NP2, NS2 NP3, NS2 NP5, NP6. That means NS, this is common. So where is the variation we are getting? In NP orbital, isn't NP1, NP2, NP3, isn't it? For example, you take example, nitrogen I'm taking nitrogen. Now, nitrogen configuration, if I observe here, 1s2, 2s2, 2p3. Now, this is what valency shell configuration. All I'm writing here, valency shell only. Now, you observe here, valency shell, 2s2, 2p3. That is nothing but ns2, np3. It is under P block only. So, in examination, they are asking these things. General electronic configurations they are asking. Now, similarly, for D block, what is the general electronic configuration? Now, in this case, you have to write ns2, n minus 1, d12, d12, same thing, ns2, n minus 1, d10 we are going to get. ns2, n minus 1, d10. That means D1, D2, D3, D4, D5, D6, D7, D8, D9, D10. NS2 is common. Okay. Only in the case of chromium, and copper, we get what? NS1 we are going to get. That is, in the case you are going to get 3D5, 4S1 we get. Here only we get 4S1. In the case of copper also we get 4S1, 3D10. Only in these two cases, we get 4s1. In all the remaining cases, we get here 4s2 only, right? So, general electronic configuration is very important. N-1 D12, N-1 D10. Common thing is what? NS2 here. Finally, what happened? F block elements. F block elements, we are writing like this. NS2, N-1, D.
It may N-2.
No. N-1. Listen carefully. 0 or 1. You may get 0 or you may get 1 also. I will explain why you are getting like that. Next, N-2, F, isn't it? 1 to what? Same thing again. NS2, isn't it? N-1, 0 or 1, and N-2, F14. So total how many will be there? In each period, you are going to have 14 elements. Totally we get 28 elements. Okay. Now see. Now, configuration, if you observe what you are going to get, N-2 F1, N-2 F2, like that, you will get N-2 F4. And this will be common. This will be common. This will be common. NS2, N-1, 0 or 1. Now, you are getting a doubt here. Why you are getting here 0 or 1? Why you are writing N-1, 0 or 1? Actually, it is N-1, D1 only. So this is for actually lanthanum, okay? Because F block elements are two types. One is lanthanum and actinum. Now this lanthanum is having like this actually. In this case, you're having 5D1, okay? 5D1 configuration. And it will have 4F0 configuration, okay? This is the lanthanum. Cerium, if I take the first element of the F block is cerium, that is having 5D1, 4F1. Now what happens here? The energy difference between the 5D and 4F is less. So that is the reason this electron may enter here. This electron may enter here. In that case, you are going to get actually what? 5d0, isn't it? 4f2 we are going to get. Now you see you got 5d0 and you got 5d1. That means this d orbital may have 0 configuration or may have 1 configuration. What is the reason? Because this one electron may enter in 4f orbital, isn't it? If it enter in 4f orbital, we'll get 0, isn't it? N minus 1 d0 we get. If it not entering, what happen? It will get what happen? N minus 1 d1. So this, the energy difference, whenever it is what very less, what happen? In that case, electron may shift from one orbital to another orbital. That is the reason I have taken here 0 or 1. So F block is little bit lengthy. S and P is very simple. Even what D also very simple, but F block is very lengthy. Ns to n minus 1 d0 or 1. Otherwise, you can also write like this also. In short form, you can write like this also. Ns to n minus 1, isn't it? d0 or 1, n minus 2, f, directly you can write 1 to 10 here also. Instead of writing everything like this, if you write like this is also correct. N minus 2, 1 to 10. Simply write like this. Similarly, the D block also you can write ns2 n minus 1 d 1 to 10 also we can write. Short form also we can write. Isn't it? Both are what? Correct. So these electronic configurations are there in the textbook also. Okay. So you note down the electronic configurations in the notebook, because definitions and configurations, isn't it? These are very important for examination point of view. Practice this one, right? Now let me do what? Next slide. I'm just roughing this one because it does not visible. So I'm just rough this one. It will be there in the textbook, no problem. Okay, but still, if it is there in the textbook, but once if you listen carefully, what happened, it will be easy for you. I'm going very slowly. I'm in no hurry. Why? Because quantity is not important. The quality is important. So I'm going slowly because most of the students, I think, slow learners will be there. So some students will get bored also. If you know what happened, they get bored also. But my attitude is that I will explain slowly and quality should get here. So that students should get understand very easy. Instead of going hurriedly, isn't it? Completing the syllabus is not important for us. So now let me see the S block elements. Again, in detail, we'll discuss about this. Already you know this definition. Differentiating electron entering in ns orbital. Better to write ns orbital, right? So definition completed. Next, it consists of two groups. What are they? First A and also what? Second A. Now the configuration, general configuration of first A is what? ns1. Second A is what? ns2 configuration. The first A group element generally called alkali metals. Second A group elements are called alkali earth metals. Now why they are called alkali metals? Because when they dissolve in water, so when these metals are dissolved in the water, they produce alkalis. Alkali means what? Basic solution. So when you dissolve these metals in water, they are producing alkalis, basic solutions. Therefore, they are called alkali metals, because all are metals only. All first A, second A, they are metals only, means they lose electron. They don't gain electron, they do lose electron. Therefore, they are called metals. So why they are called alkaline earth metals? Because they extracted from the earth crust. But beryllium is not at all called. Remember, beryllium does not called as alkali earth metal. Okay, it is not called as, because it is not available on the earth crust, not called as alkali earth metal. But it can called as what? Second A group element. It can be called as second A group element, but cannot called as alkali earth metal. Sometimes you may get a question like this: following which is not an alkali earth metal? By giving something beryllium, magnesium, calcium, strontium, in that case, the answer must be beryllium. Beryllium is not at all having, isn't it, alkali earth nature here. Okay, so this is about the classification, first A and second A group elements here. Now, whether you need to remember the elements, no need, but at least up to here, at least remember up to here, at least up to here. Okay, I told you up to 30 you need to remember, So lithium, sodium, potassium, beryllium, magnesium, calcium, better to remember up to 30. This is already I told you, NS1 configuration, NS2 configuration. First year will have NS1, second year will have NS2 configuration. Now, some important points about the S-black elements, some important properties of the S-black elements. All are metals. I told you all are what? Metals only. And they're having very low ionization enthalpy. Now, what is the meaning of low ionization enthalpy? First of all, low means everyone knows that. Now, what is the meaning of ionization enthalpy? Ionization enthalpy means what? The amount of energy is required to remove outermost electron. Okay, how much amount of energy is required to remove outermost electron? Okay, now what is the configuration of first year? Tell me. What is the configuration of first year? Are you there?
NS1.
NS1, right? Now, ionization enthalpy means to remove this NS1 electron, how much amount of energy is required, that you are calling as ionization enthalpy. Definitions will be what something what lengthy, but I'm saying in short, how much amount of energy is required to remove this NS1 electron is nothing but ionization. For example, lithium is there. Lithium configuration is what? 2s1. Now I want to remove this 2s1 electron. To remove this 2s1 electron, how much amount of energy is required? That energy you are calling as ionization enthalpy. Now what I'm saying here, all first year group elements, they are having not only first year, all S-black elements, all S-black elements are having lower ionization enthalpy. That means for S-black elements, we can remove outermost electron very easily. Very easily means nothing but less energy we can use actually, isn't it? So by using the hand, we can't remove that one. That is different thing. But when you compare with different elements, these are what easy, isn't it? So what I mean to say is that the S-block elements are having low ionization enthalpy. For example, you will get in different type of questions following which is the correct statements. In that what happened, they say S-black elements are having high ionization enthalpy. That's a wrong statement. So like that you will get some questions. So what I mean to say is that here S-black elements are metals and they're having low ionization enthalpies. Next, they show +1 oxidation state and also what? +2 oxidation state. Why they are getting? Which one? Group 1. First year is getting +1. Why? Because in S1, how many electrons are there? In this, how many electrons are there?
1.
That means in outermost shell, valency shell, only 1 electron is there. It can lose only 1 electron. If it lose 1 electron, the oxidation state will be +1. Plus is means how many electrons it is losing. Plus means how many electrons losing. How many? 1. So +1. Now, if you observe secondary group element, the configuration will be NS2 configuration, right? So how many electrons it can lose here? Only 2 electrons it can lose here, right? So it will get here again +2 oxidation state. So S-black elements can show 2 different oxidation state. First year will show +1, second year will show +2 configuration, right? This is about the S-black elements, isn't it? One more thing, because of high reactivity, generally S-black elements are very reactive in nature because they are having only 1 electron they can lose and after losing the electron, you know, they are getting octet configuration. Okay. Now somebody will ask you why the S-black elements are highly reactive. If they ask like this, you just note this point also in your notebook. Note this point. Just don't listen to the class. You need to make a notes also when you are listening to the class. What happened? Make a notes also. Why S-black elements are highly reactive? Very simple. When they lose NS1 electron or when they lose what happened NS2 electron, they are getting stable octet configuration. They are getting what? A stable octet configuration. Octet configuration means what? In valency shell getting 8 electrons. See, in any element, generally what happened? You will get a doubt actually. Why do elements undergo chemical reaction? Why an element is undergoing chemical reaction here? Why the elements are having chemical reactivity? Because only the simple reason, the elements want to get the octet configuration. The elements want to get the 8 electrons in the outermost shell here. Whenever if they get 8 electrons in the outermost shell, what happened? They get the stable here. This is a fundamental thing. So here also in S black elements, if they lose what happened, ns1 electron, isn't it? If they lose ns1 electron or ns2 electron, they're getting what type of configuration? Octet configuration. So for gaining octet configuration, these electrons, ns1, ns2, losing readily, therefore they're having high reactivity, isn't it? And they are found in pure, they are found in pure state? No, they are never found in the pure state. Why? Because see, how do they lose electron? So there you are saying what happened? By losing that electron, they are getting octet configuration. Now question is that how do they lose electron? So by forming some chemical compound. For example, lithium is there. Lithium, how it lose that 2s1 electron? By converting into lithium plus actually. By converting into, how it convert into lithium plus? By converting into lithium chloride. If it convert into lithium chloride, lithium will get positive oxidation state. So understood my point here. So they lose electron by participating in a chemical reaction. Once they participate in the chemical reaction, they are now converted into compound state. They are converted into compound state. So lithium never found in the pure state. So in examination, if they ask something, why S black elements are not found in the pure state or elemental state on earth crust? Reason is what? Very simple. They are having high reactivity. Simple thing, because of their high reactivity, they do not available in pure state. They available in which state actually? In compound state, like lithium chloride, sodium chloride, or sodium bromide, or magnesium chloride, calcium sulfate, like that they are available. So this is my point to explain things here. Okay, right. I think it is understood, everyone. Understood or not?
Yes, sir.
Now
Understood,
let me
sir.
see here. Now let me see one more point. Metallic character. Metallic character. Metallic character down the group. That means top to bottom like this. Top to bottom, metallic character will increases. Now, if anybody asks you what is the meaning of metallic character, simple thing, losing of electron. Losing of electron. The tendency to lose electron. Losing of electron. The tendency to lose electron is called what? Metallic character. Now, at ionization potentials, if you observe, they are having very less, and down the group. If I see what happened, I'm writing here lithium configuration 3s1. Here it will be 7s1. Now, this electron, the single electron, is present in the 7th orbit. So that is away from the nucleus. So we can remove easily that electron. It can lose electron also very easily. On its own, the 7s1 electron will be lost easily, but 3s1 something difficult to lose. Why? Because it is near to the nucleus. Nucleus actually attracts that electron. So when it is attracting the electron, isn't it? Removing what? Very difficult. Losing is very difficult. So 7s being what? Actually away from the nucleus, you can remove easily. It can lose electron easily. That is the reason 7s is having very low ionization potential. In examination, if they ask you which element in the periodic table is having lowest ionization potential, that is actually what? Cesium. Cesium. We are not taking francium. Why? Because francium is unstable. This is a radioactive element. So of course, theoretically it is a francium only. Theoretically, absolutely it is a francium only. But francium is actually having very, very less, isn't it? What we call half-life period. Only what having 21 minutes, something like that. Half-life period is only in minutes only, 21 minutes like that. So because of highly unstable, no. So we are practically, you are not taking the francium. Practically, we will take actually what? Cesium is the answer. Critically, francium is right. Now, what I'm saying here, top to bottom, from lithium to francium or cesium, because francium is radioactive, leave it that way. From lithium to cesium, what is happening? Losing of electron tendency is what is increasing. So losing of electron tendency increases. What happened here? Metallic character also increases here. So you need to remember only this point here. Metallic character generally in any group, not only in this group, not only in S black element, in any groups if you observe, in any block if you observe, top to bottom, that means what happened? First, second period to what? Last period, it will always what happen? Increases only, because they lose readily electrons. The reason is because they lose readily electrons. So here in this slide, what I explained here, metallic character generally what happened? Increases from down the group actually. We move to next slide. Now this some statement is there. Let me see what is this statement again. Now in this statement, except lithium and beryllium, the remaining elements form ionic compounds with 6th and 7th group elements. 6th means nothing but oxygen family. 7th is nothing but fluorine family actually. So lithium and beryllium, they will form covalent bonds. For example, if I write what lithium chloride, this is having it will have ionic nature is there, but dominantly it will have covalent character. Covalent character. You know already covalent bond. Now, for example, sodium chloride will be have ionic character. Similarly, what happened? Beryllium chloride will have what type of character here? Covalent character. Okay. Whatever the compounds formed by the lithium and beryllium will have what type of nature? Covalent nature. And remaining elements like sodium, potassium, rubidium, cesium, barium, strontium, calcium, magnesium, they predominantly will have ionic nature. Okay. Now, with which group elements? 6th and 7th group element. This will discuss in the S-Black elements separately in the chapters. So just I want to inform you this point only. Thing is that lithium and beryllium will form covalent bonds, remaining will form ionic bonds actually. Now coming to what P block elements. Next second block will be P block actually. Now already I mentioned what about the definition already mentioned here. So no need to go for definition here. Very simple. NP orbital. Okay. The differentiating electron is entering in the NP orbital, and which groups they are having? 13th group to 18. This is the thing. 13, 14, 15, 16, 17, 18. Okay. Remember up to at least here. At least up to here. It is better for. This outermost shell configuration will be NS2 NP1 to NS2 NP6. For example, this will have, this family will have NS2 NP1. This will have what? NP2. This will have NP3. Finally, this will have NP6 actually, right? Next, each period ends with a noble gas which is chemically inactive. For example, which period is actually first period? This is second period. This one will be third period, fourth, fifth, sixth, seventh. Isn't it? This is OG, organesson 118. This will be TS. Okay, tennyson something around 117, something like this. Okay, last element if you observe. Now, each period ends with what actually? Noble gas. What is noble gas generally? Because the reactivity is what? All are gaseous molecules. The group 18 contains what happened? Group 18 contains all are what? Gaseous molecule. Helium to what? Organesson. All are what actually? Gaseous elements only. They are noble because their reactivity is what? Very less. Therefore, they are called noble gases here. Now, each period, first period to seventh period, element ending with what? Noble gases. See, first period ending with helium, fourth period ending with krypton, and last period is ending with organesson. This is the statement. And all are what? Chemically inactive. Okay. Except xenon, what happened? Remaining all are what? Highly chemical inactive. At least xenon is having little bit chemical activity is there. Now, it contains all types of elements here. Okay, generally, if you observe S-Black, which type of elements are there in S-Black? Anybody? In S-Black, what type of elements? All are what?
Metals.
Metals only. So, sometimes you know which group contains all are metals? S-Block containing what? All are what? Metal. Even what D-Block also contain metals only. But sometimes you may get a question. Which block contains non-metals, metals, and as well as metalloids? That means we can say even amphoteric also. They comes under in P block elements. Now, non-metal means you know that one. Gaining of electron tendency. Metals means what happened? Losing of electron tendency. Metalloid means intermediate. It may lose or it may gain here. So generally what happened? Metalloids will comes here actually. At the middle what happened? Generally metalloids will come. Top generally will have, for example, top elements like this. Generally top elements will have what actually? Non-metals. Top elements will have non-metals. These are leave it this one. Because these are not comes under any type of nature. Okay, leave it the group 18. Now generally what happened? Second and third period will have non-metals. Aluminum is a metal. Some exceptions will be there. And this fourth and fifth period will have what actually? Metalloid character. These are metalloid character. And last elements will have what actually? Metal character. So that means what happened? Generally what happened? Second and third period will have non-metallic nature. fourth and fifth period will have metalloids, and finally what happened, sixth and seventh will have metallic type. Now what about the amphoteric nature means? Amphoteric means metal which can react with acid and bases, they comes under what? Amphoteric nature actually. That we'll discuss in later, what are amphoteric and everything. Here it is not important for us, isn't it? So what I mean to say is that P block elements will contain all type of natured elements, non-metals, metals, metalloids, and amphoteric metals. Here. They are very close to noble gases. Two chemically important groups are there. The non-metals are present. They are called chalcogens and halogens. For now, for example, if you observe here what happened, whichever the group element is what near to this noble gases here. Okay, they are actually what actually this group and this group. That means what happened, 16th group and 17th group. Generally 16th group is called chalcogen, okay, and 17th group is called what? Halogens. Now these are having high reactivity, so which are near to what these zero group elements are having high reactivity. Why? Because you know this fluorine, if it gain one electron, what type of configuration it will get? Anybody? If fluorine get one electron, what type of configuration it will get?
Okay.
Neon, octet configuration or neon configuration, which is what? Noble gas configuration. So if it gain one electron, it will get noble gas configuration or octet configuration. Now for getting that stability, gaining the electron is immediately it is gaining electron. That is the reason it's having highly reactivity. So they are very close to the noble gas. That is the reason they're having high reactivity, isn't it? This is about this statement. Generally, chalcogens will form mineral compounds. You see, for example, generally zinc oxide, isn't it? Most of the compounds, if you see zinc sulfides, isn't it? These are minerals actually. So that is the reason they're called chalcogens. Okay. Now, halogens means salt-forming elements. Generally, sodium chloride, isn't it? Magnesium chloride or sodium fluoride. So these are nothing but salt forms, salt compounds. Therefore, salt-forming compounds are generally what happen formed by the halogens here. So these are things actually. So now we'll see something here. A note we'll see here. Elements of S block and P block, except noble gases, are collectively called representative elements. This is important for us. Or normal group normal elements. Normal, nobody asks you. Simple, remember, representative elements. Now, simply they will ask in examination, following which are representative elements, which group elements are representative elements? S block and P block, except noble gases. Noble gases are not at all called what? Representative elements. Why? What is the reason? See, because they are having completely filled configuration, isn't it? So for getting the representative nature, they should have incomplete configuration. You may ask here, NS1 incomplete. NS2 is not completed filled because still NP is 0, no? NP is 0, no? So it is not completely filled. Now NS2, NP1, NS2, NP5. Finally, what happened? NS2, NP6 here. Now you observe what happened. They are having completely filled configuration. After NP6, there is no orbital here, isn't it? So that is the reason what happened. They are not comes under representative elements. Again, I am saying which elements are called representative elements. Tell me which elements are called representative elements. Do fast. Which elements are called?
S block and P block elements except noble gas.
Except noble gas. Remember this one. Sometimes they make you like this also by giving what? Barium, isn't it? Something SB, something what happened? Iodine, and something what? Xenon. Now they ask following in which element, which of the element is not something what not a representative element. Like that also they will ask by giving some second option, third option, fourth option. Which element is not a representative element? Simply you have to give the answer what? Which option you have to give answer now?
So fourth. Noble gas.
Xenon. Xenon is not at all called. That means you need to remember these elements. At least remember something. At least you observe what happened. No need to if you observe the symbol, you should know which group it is. Like that also, they may ask some questions also. Right. Tell me the answer for this one. Do fast. Outermost electronic configuration of alkali metal.
NS1. NS1.
B answer, right. Now tell me what is the answer for this one. Like elements Right?
Increases.
Higher D.
Increases.
Increases, right? This is about the only P black. Now in the next slide, we'll see the next PPT. We'll see the P black. Now this. Now let me see the third one, D block elements. Definition you know already. The elements in which what happened? Differentiating electron enter in n minus 1 d orbital, isn't it? They are nothing but n minus 1 d orbital. Right? These are called D. Now what about transition element? I will explain, no problem. The transition elements are different. I will explain after this D black element. When it is over, I will explain this. Okay. Now, for example, the properties are active S black elements. This I will explain later. The first slide I will explain later because it is not important for us. First we see the, it's not there. First of all, everyone knows, no, this D black where comes under actually? Just all right. Elements in which differentiating electron enter in n minus 1 d orbital, isn't it? They are called D black elements. It consists how many groups actually? 10 groups. How many groups it is having? 10 groups it is having. What are they? Third group, fourth group, fifth group, sixth group, seventh group, eighth group, ninth group, 10th group, 11th group, 12th group. Otherwise, third B group, fourth B group, fifth B group, sixth B group, seventh B group, and 8 and 9, 10 collectively called 8th B group, because what reason behind? They are having similar properties. Iron, cobalt, nickel, their properties are similar. Therefore, they are taken under same group called 8th B group. This is called what actually? First B group. This one is called second B group. Now, how to remember? You see second, right? Second. See, one last letter if you observe, last number if you observe what happened. First, isn't it? Here what happens? Same, 7, 7, 6, 6, fifth, like this. For example, third A group, nothing but 13th group, 3, 3. Fourth A group, which group it is? 14th group, 4, 4. Sixth A group, isn't it? Nothing but 16th group, 6, 6, like. You can easily remember, no problem for us. Okay, now you got what are the elements are present in the D block? There are 10 groups are there. You see, from third B to second B, there are 10 groups are there. Otherwise, from third group to 12th group, there are 10 groups are there, and each group is containing what actually what? 10 elements here. So for this generally it is called 3D series. Remember, it is 3D series because differentiating electron enters in 3D orbital. Now this is called what? 4D series. This is called what? 5D series. This is called what? 6D series. Now 3D series starts from what? Scandium to zinc, isn't it? Scandium to zinc. Now next one, 4D series starts from what? Yttrium to what? Cadmium, isn't it? 5D series starts from lanthanum to what? Mercury. After 57, 58 will be in a black element. Remember that one, 58 will be in a black element. So 57, next we get 72 to what? Mercury. Next finally 60 series start from where? Actinium to what? Isn't it? Copernicium, Cn. Cn is nothing but what? Copernicium, isn't it? This is Cn, copernicium. This is about all these elements of D block element here. Okay. Now why I call this one 3D series? Anybody tell me why I call this one 3D series? Do fast. Are you there?
Yes, sir.
Tell me why you just call 3D series? What are 3D series elements means? Scandium to zinc is called 3D series. Okay. 4D series means yttrium to cadmium. So why I'm calling 3D series here? What is the reason it is called 3D series? What is the reason it is called what? 4D series? Why you are calling this as a 5D?
So because the valence electrons enter.
The differentiating electron is in 3D orbital. The differentiating electron in 4d orbital. The differentiating electron in 6d orbital. Therefore, they are called 3d series here. Now, 3d series belongs to which period? 4th period. 4d series belongs to which period? 5th period. 5d 6th period. Like that it is. Because n minus 1 orbital known, n minus 1 d orbital known. N is equal to what here? 4 here. Isn't it? So, they about the things. Next. The general outer mode configuration, already I mentioned this one, n minus 1, b 1 to 10. This is 1 or 2. 1 or 2 I have written why? Because for chromium, you will get 4s1, 3d10. Only for chromium and copper, you will get 4s1 configuration. So you can write here also 1 or 2. Either 1 or 2 you will get here. 1 to 2 or 1 or 2 we can write here. They're all metals. Similarly, just like S-block elements, these are also what? All are what? Metals only. They mostly form colored ions. For example, if you observe what happened, copper sulfate, which color it will have? Copper sulfate will have blue. What happens if you observe ferrous sulfate, will have something brownish color like this. So when they form some compounds, the form of ionic nature, they form some colored compounds actually, right? Next, they exhibit variable oxidation state. Now tell me what is the meaning? Anybody knows what is the meaning of variable oxidation state? If you
No,
do,
sir.
if you know, you explain me. Otherwise, what? If anybody knows,
Sir, they lose electron variability.
okay. Let me take some example here. I have taken first A group element. Okay. Tell me any element of first A group element. First A group. Any element of first A.
Sodium.
The potassium.
Sodium.
Potassium can show only one oxidation state, that is +1. Similarly, if I take second A group element, calcium, if I take calcium, show only +2 oxidation state. That means they will show only one type of oxidation state. But if you observe D black elements, they show many number of oxidation state. They show what happened? Many number of oxidation states here. For example, you take iron. Iron show +2, iron show +3. Copper will show +1, copper will show +2. Manganese will show +2, manganese will show +3, manganese will show +4, manganese will show +6, manganese will show +7. See, different number of oxidation states you are going. Many number of oxidation states you are going to get. So single element getting many number of oxidation states, that is nothing but called variable oxidation state. Now the D black elements will show variable oxidation state. Now they show paramagnetic nature. Now you know what is the meaning of paramagnetic nature? The meaning of paramagnetic nature.
No, sir, we don't.
Yes.
They can act like a magnet.
If you place these elements in magnetic field, they attract things. So they will attract the element, whatever the elements, isn't it? For example, iron is a paramagnetic nature, attracts the magnetic field. So exhibiting magnetic properties, nothing but what happened, attracting the things here. So that we'll discuss in later in the 12th class, we get that one. Next, they can be used as a catalyst now. They can be used as a catalyst. Catalyst means what happened? An element which can increases the rate of reaction is called what? Catalyst, which will change the rate of reaction. It's called what? Catalyst, isn't it? For example, I want to prepare ammonia. So normally ammonia does not prepared by nitrogen plus hydrogen. What I have to do? I have to use iron as a catalyst. Because of this, what happened? The rate of reaction will be increases. Now let me see what happened. This is about the elements again. I'm writing here. These are all what? Elements. You see, all are what? Elements actually. Next. Now, one thing, this is now like let me take transition elements. We are writing what transitional elements. What is the meaning of the transition elements? Let me see. Now, I will make a statement here. All D block elements, see, all D block elements are not called transitional. All D block are not transitional. Are not transitional. But all transitional elements are called as what? D block. This is very, very important statement. All D block cannot be called transitional, and all transitional elements are called D block. Whoever listening to the class, for example, whoever present in the class, what happened? They do not listen carefully. But who are listening to the class, they are present in the group actually, in this group actually. Same thing like that. All D black are not transition element, but all transition elements are called D. Let me see what is this meaning of this one. Now, for example, zinc, cadmium, and mercury. Zinc, cadmium, and mercury. Where are they actually? If you observe what happened, where are they? You see here. They are here actually. Here, which group they are considered? Second B group element. Now, anybody tell me what is the general configuration? What is the configuration of second B group element? Anybody? Is possible? So second B configuration.
D10.
3D10 4s2.
So they are having n-1 D10 ns2 configuration, right? All are having. For example, this is having 3D10 4s2. So this is having 4D10 5s2. This is having 5D10 6s2. Having what? 6D10 then 7s2, right? Now what I mean to say is that now when you observe these configurations, all are what? Completely filled or not? Completely filled or not? They are completely filled, right? Now whenever electrons are completely filled, their chemical properties are getting what? Different here. Their chemical properties will vary actually. So second B group elements, these second B group elements, isn't it? They are not called transitional elements. They are not comes under transitional elements here. Why? Because they are having completely filled configuration. Understood here? So when you observe remaining elements, they are having incomplete configuration. For example, scandium 3D1 incomplete, chromium 3D5 incomplete, cobalt 3D7 incomplete here. So incomplete d orbital, incomplete, isn't it? I'm writing here. You will write incomplete, isn't it? Incomplete, isn't it? n-1 d orbitals generally comes under transitional elements. Now, in anybody, if you ask what are transitional elements, the answer must be incomplete n-1 d orbital elements are comes under transitional elements. Why? Zinc, cadmium, mercury, second B group elements do not called as transitional elements because they are having completely filled configuration. See, they are having completely filled configuration. But here you will get a one doubt actually. If you see, observe again this one, copper, the 29 atomic number, if you observe, copper configuration will be 3D10, right? 4s1. Correct or not? Tell me. Copper configuration, if you observe.
Yes, sir, correct.
3D10. Then 3D is completely filled, no? 3D10 completely filled, no? Then how you are calling this one transition element? In that case, the answer must be, shall we take like it? Copper, when it lose 2 electrons, copper plus 2, right? Generally, copper sulfate will be in terms of plus 2 only. Now, configuration here, what actually? 3D10, 4s1. Now, here, what is the configuration? Copper, copper plus anybody? Copper plus 2.
3D9.
3D9. In their oxidation state, they are getting incompletely filled configuration. When it lose electron, you are getting incomplete configuration. That is the reason these are called typical transitional elements. These are called actually typical transitional elements. So they are transitional elements. But again, one more doubt you get. What about zinc? If in the oxidation state, if you observe zinc plus 2. I am writing zinc plus 2 here. Now, zinc configuration. Tell me what is the zinc configuration?
3D10 4s2.
3D10 4s2. Now, after losing the 2 electron, where you have to lose, generally if they ask to remove electron, we need to remove from outermost shell. Okay, don't remove from 3D because we need to remove from outermost shell. From 4s orbital, we need to remember. So in that case also it is 3D10, even though in oxidation state also, isn't it? It is exhibiting what actually? Completely filled configuration. So generally this 2B means what actually? Exhibit plus 2 general actually. So that is the reason I have taken like that. So understood my point here? Very simple here. Zinc, that means what happens? Zinc, cadmium, mercury, which belongs to actually second B group element, isn't it? Which belongs to second B group element. They are non-transition elements, but that belongs to d black element. Why? Because the differentiating electron entering in the d orbital only. So they are called d black, but they are not called transition elements. But copper also having 3d10 configuration, but in their chemical nature, what happened? It will lose electron in copper plus 2, will get again incompletely filled configuration. Therefore, they are called typical transition elements. Now, these properties, when you observe, the chemical active metals S black, less active elements in P black, that transmitting. For example, if you observe the periodic table, let me see again the periodic table now. Periodic table here, okay, no problem. You get that one now. We see one periodic table here. Now here. Now if you observe what happened this periodic table, now S black, P block, D block and F block. Now what is happening? S blacks are what? Very highly reactive, more reactive. These are what? Very high reactive, more reactive. Of course, the fluorine is having high reactive, but generally what happened? They are very less reactive when compared to this one. They are less reactive because they are losing of more number of electrons. It lose actually. Now D block being present between the S and P block, D block will have intermediate properties between what? Intermediate properties between what actually S and P block. So because being in middle, what happened? The reactivity, what happened from here to here, what happened? Decreasing. That means what happened? The properties are changing from S black to P black through what actually? D black. That means they're transmitting through what? S to what? P black. Therefore, the name they given actually transition element. But the definition is of actually incomplete, isn't it? Whatever the incomplete n-1 d orbital configuration generally called actually what? Their properties are between the chemically very active metals such as what? S black and very less reactive elements like group 13 and 14. Because 13 and 14 I am considering because after that 16, 17 what? Which are near to our noble gas configuration. No, 16, 17 group is already I told you they are near to noble gas configuration. So I am not considering this one. So they are what called transitional elements. So this is about the transition elements. Next we will see the F block elements. Now inner transition they are called. Inner transition because n-2. That n-1 is a transition, no. n-1 orbitals generate transition, no. Now n-1 inner is nothing but n-2. Therefore, they are called inner transition like that. But again, let me see again. And these are the elements of what? F block elements. Now in this series called what? 4F series. This one is called what? 5F series. This belongs to 6th period. This belongs to 6th period. This belongs to what? 7th period. Now n is equal to here what? 7. Here n is equal to here what? 6. Now n-2 is equal to what here? 4. Here n-2 is equal to what actually? 5. Therefore, the differentiating electron is entering in which orbital? 5f orbital. Your differentiating electron entering in the 4f orbital. So cerium to lutetium, atomic number from 58 to 71 is present in which series? 4f series. Again, 5f series contain what? Thorium, atomic number 92, atomic number 103, lawrencium, isn't it? There belongs to what? 5F series. So you have to remember that elements, first element, last element, atomic numbers you need to remember compulsory, isn't it? So even in the D block also, what you have to remember actually? The first element in 4F series. What is that? Cerium. To what? Lutetium. Atomic number will be 58. Atomic number will be 71. In 5F series, thorium, atomic number 92, what actually? Lawrencium, atomic number 103. So the last number, atomic number, first atomic number, and similarly the first element symbol and first, second, last element symbol compulsory you have to remember, because in examination it will be useful for you. First and last number. From that only we can calculate the remaining atomic numbers. Next, if you observe what happened, the elements in which definition already we know this one. Any number of times we discuss this one. n-2f orbital, the differentiating the last electron will enter. So they are called what? F block elements actually. Their outermost configuration will be what actually? This will outer NH2, n-1, 0 or 1, 0 or 1. and n minus t of 1 to what? 14, isn't it? Next, yellow shaded elements are man-made elements. See, so man-made elements is nothing but synthetic elements. So actually what happened? Any element after the uranium means what happened? 92 atomic number, greater than the 92 atomic number. Any element comes after 92, they are synthetic elements only, they are man-made elements. See, for example, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendeleum, nobelium, lawrencium. All these elements are synthetic elements, except one, promethium. Promethium in 4f series, all are what? Natural elements only, except one, promethium. So promethium is a synthetic element. So in the 4f series, only one element is a synthetic, that is called promethium. PM is nothing but called promethium. That is a synthetic element, man-made element. But in the 5f series, except 3, thorium, protactinium, and uranium, remaining elements are what? Synthetic elements. That means after the 92, whatever it may be, even 104, 105, 106, 107, anything it will be, all are what? Synthetic element, isn't it? It contains 2 rods. The 4f series is called what actually? That means cerium to what? Lutetium is called lanthanide, because they are after the lanthanide, therefore called lanthanides here. And 5f series, isn't it? The 5f series, isn't it? This one. This one is the 4f series, and the 5f series is called what? Actinides here. Okay. Actinide starts from 92, 103, 58 to 71. All are the metals only. That means S block, B block, and A block. All are what? Metal. Only in the P block only we get metals, non-metals like that. And all actinides are radioactive elements. See, from thorium to lawrencium, all are what? Radioactive elements. In this one, promethium is also radioactive, because the man-made element also what? Radioactive. Even promethium. Now they will ask one question. In 4f series, which element is radioactive element? Which element is radioactive? Promethium is the radioactive. In 5f series, which element is radioactive element? Tell me. In 5f series, all are what? Radioactive elements. No. Generally, they show what? Normally, they show what? +3 oxidation state. Why? Because if you observe the configuration, why they show +3, I will explain this one. If you observe the configuration, what will be? NS2, N-1, D1, isn't it? N-2, F orbital, 1 to 14. Now, they lose these 2 electrons, they lose this 1 electron. Total, they lose commonly which electron they lose? 2 + 1. Therefore, they show common oxidation state will be +3 only. See, that is the reason they are getting +3 oxidation state actually. Now, these elements after uranium, they are called transuranic elements. What is the meaning of transuranic elements? Means after the uranium, all are what? Radioactive elements. That is the meaning of transuranic elements. Now, what are transuranic elements? Elements after uranium are called transuranic elements here, right? Elements from here. These are all what? Transuranic elements. Now, let me see some questions on this one. The general order configuration of D block is. Tell me, which is the correct answer? D block.
So B.
This something what happened? N-1, N. It should be correct, isn't it? This is N, so it will be wrong actually. So B is the answer. And what happened? We get confused. Don't give answer in examination hurriedly. See options B. You have more time will be there in examination. So all the options are. Sometimes what happened? The student they see only 1 to 10 only. So by seeing 1 to 10, they say something ND also. So don't do mistakes by seeing what happened like this. You have to see all the options. Then only you have to give the answer. Seeing only one option, don't give the answer. This will be, what will be the answer? In examination, what happened? All look same only. 1 to 10, 1 to 14. It looks 14, 114, 1 to 10. Everything looks same only. So key point will be what?
Sir, A.
N-2, N-1. This you have to consider.
A.
Right. Very good. Now, a small topic is there. Only 5 minutes I will take, up to 10-15. So, one more classification is there. Metals, non-metals, and metalloids. The periodic table, it is classified into SPDF. No, similarly, in periodic table also classified into metals, non-metals and metalloids here. Three type of classifications are there. One is called metal, non-metal, metalloid. Now let me see how they are, where their metals are there. Now I told you already, I told you in many number of times, all S block, all D block and all F block, all comes under metals only, isn't it? S block, isn't it? That means this is one, S block. That means what happened? First A, second A, they comes under metalloids. Next what happened? All D block, isn't it? That means transition elements. Okay, they comes under what? Even you can take this one also metal only. Zinc is a metal only, no problem. Don't consider that zinc is not metal. No, zinc is a metal. Even mercury also. Tell me which metal is in liquid state?
Mercury.
Mercury. See, not all D black. Best better to write D black.
Mercury.
Have you seen mercury?
Yes, sir.
Sir, in thermometer.
Which non-metal is liquid state? Which non-metal is liquid state?
Chromium.
Chromium. Here it is. Now, F block is also comes under metals. So let me see this one later. Post transition metals we will see later. Okay, this one we will see later here. Whichever comes all, let that we see that one. Next will be see F block elements. No problem. All let me see. First of all, let they come. Let me see now here. Alkali metals, this one. Alkali earthy metals, this one. Transitional elements means everything. Transitional elements, including what you take everything, all these things. D block, let me take. See what D block. Next, what happened? Lanthanides, actinides. Okay, all these are actually metals only. Now, where we get non-metals? The non-metals, even with aluminum is a metal. Post-transition metal means like this. Post-transition metal means this part. This part, you see, this part is actually aluminum part. These are post-transition metal. After the transition, post means after. Generally, what is the meaning of post? After. After transitional metals, you are writing this one. Which one? Aluminium, isn't it? Gallium, this part. Aluminium, gallium, isn't it? Indium, thallium, this part. All these elements actually. Nihonium, flavonium, marconium, livermonium. They comes under what happened? Post-transitional metals here. Next, this part if you observe, silicon, isn't it? Germanium, lead, antimony. This can called SB called antimony. This is called antimony. Next, tellurium, isn't it? These are actually comes under what? Polonium. They comes under actually metalloids. They're having intermediate properties. Halogens, already you know this one. Non-metals. These are non-metals. Inert gas also called non-metals only. Lanthanides and actinides are called metals. So now we get an idea here. What are the metals? See, all S block, D block and F block, they comes under metals. Now which comes under non-metal? In P block. In P block, these comes under boron, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, selenium, chlorine, bromine, iodine, acid. These all, whichever a tick mark here, no, they come, sorry, this one. All these comes under wherein actually non-metals here. This is non-metals. These are not called non-metals because they don't gain electron, no. So these are not at all called inert gases, we can call this. Inert gases. These are called inert gases. So what are the non-metals we're having? Boron, carbon, nitrogen, oxygen, fluorine to what? Astatine. All comes under what actually? Non-metals only. Selenium, sulfur, phosphorus, they comes under non-metal. Now which are what? Metalloids. If you consider it, metalloids are nothing but this one. Germanium, silicon, germanium, arsenic, antimony, tellurium, polonium, they comes under metalloids. Okay. Now, generally, the meaning of the metalloids, electropositive character. What is the meaning of electropositive character? losing of electron, isn't it? Loss of electron. There comes under first J group element are having, which group elements are having highest electropositive element in the periodic table means first J group elements, isn't it? And modern periodic table consists almost 78% is nothing but metals only, and they are placed in the left hand side of the periodic table. Now, generally metals are very solid in nature. All metals are solids, but mercury is what? Liquid nature. And they're having high melting point, boiling points. But some exception is there. Gallium melting point is very, very less, around something room temperature, 25 something around degrees Celsius. When you take that gallium on your palm, on your hand palm, it will melt actually. So generally what happens, all metals will have high melting point except gallium, which is having very low melting point. Even what happens, cesium is also having very low melting point because their bondings are very, very weak actually. They're very good conductor. They conduct electricity. They're malleable, ductile. Malleability means what? Beating into sheets actually. Ductility means deriving into wires actually. Copper is a very good wire we are using for conducting the current. No. Malleability means aluminum. Aluminum sheets, generally we use aluminum sheets. So beating into sheets, nothing but aluminum malleability, and deriving into wires, ductility, copper like that. Even gold also. Next, trends in the metallic character in groups, in periods. Generally observe one thing actually, down the group, metallic character always increases. For example, lithium to francium, cesium. Leave it this point because a radioactive element. So metallic character, what happened? Increase. Any group, if you observe, it will increase. Now for period, what happened? Per period, it will increase. So down the group, generally what happened? Metallic character increases. And in period, what happened? Decreases. See, sodium is a metal, right? Sodium is a metal. Otherwise, you take potassium. Potassium is a metal, right? Potassium is a metal. Now, observe same period element for last one is what? Bromium. Bromium is what here? Non-metal. Bromium is non-metal. So, metallic character decrease or not? Yes. Metal to what? Non-metallic character. It is decreased here. So, in groups, down the group, metallic character increases. In period, left to right, it will decreases. Which character? Metallic character. Tendency to lose electron will be decreases in period, increases in group action. This one is the thing actually. Trends in the metallic character in groups and periods. This is a very important point. Same thing, it is electropositive character increases down the group, decreases left to right in the period. This is a very important point you need to remember actually. I think you know this answer, mercury. Everyone knows this one. Tell me an answer. What about this one? Which answer correct one?
So all of the four
above.
All are what?
All the
Malleability, good conductor. Right. What about the non-metals and the metalloids? Small topic it is, non-metals. They are more electronegative. Generally, metals are what? More electropositive. But non-metals are more electronegative. Example, we'll take 7th A group. Generally, what 7th A group are? Highest electronegative, highest non-metallic character, highest. First A group is what? Highest metallic character. Highest electropositive character. But 7th A group is what? Highest electronegative character, highest non-metallic. Why? Because if they gain one electron, they will get what? Octet configuration. So for gaining that electron, what happens? They undergo more reaction. All non-metals are present in the right hand side. Generally, non-metals present in the P black element. No, P black present where in the right hand side. Except what? Hydrogen also non-metal. Of course, hydrogen will lose electron. Hydrogen will gain electron also. That is a different. But hydrogen, when it gain one electron, what happens? It will get hydrogen -1, which is a helium configuration, 1s2 configuration. So hydrogen also a non-metal actually, right? What are the characteristics? Generally, what happens? Non-metals are solids, gases also there, liquids also there. See, for example, nitrogen gas, chlorine gas, fluorine gas. For example, if you take what happened, iodine solid, bromine is a liquid. That means non-metals may have solid nature, gaseous nature, liquid nature at room temperature. And the melting points, if you observe, compared to the metals, their melting points and boiling points are very less. But boron and carbon, if you observe what happened, they're having Which element is having highest melting point in periodic table? Anybody? Which element is having highest melting point?
Carbon.
Carbon only. Which element is having highest melting point is carbon. Which metal is having highest melting point is tungsten. Okay. Tungsten is having highest melting point in terms of metals. In terms of elements, carbon is having highest melting point. And compared to that one, there are very poor conductors of electricity, and most of them are brittle in nature. Brittle in nature means what happened? They breaks very easily. Just like what happened, you see, that means when they break, what happened, they will get a shape like this. For example, you take any crystal, solid crystals like sugar, will have a brittle. That means if you cut, what happened, you will get again same shape only. Okay, if you cut that sugar, what happened, all particles will have same shape. We don't have different shapes actually. But if you cut plastic, what happened? Break the plastic, we'll get different shapes. But if you crush the sugar, what happened? You will get all particles will have same shapes only. So they are not, they can't call malleability. They cannot be called ductility. These are you don't have for the non-metallic character. Now, what are the trends in the groups and the period? So opposite to the, don't remember these properties. Leave it this one. Because if you remember this one, what happened? You will get a doubt here. You will get a confusion here. So remember for the metallic characters, and whatever the non-metallic will be opposite here. So what is the metallic character? Top to bottom increases, but non-metallic character top to bottom decreases here. So it will decreases here. So don't remember this one. Opposite to metallic characters are non-metallic characters. Though you need not to avoid confusion, what I am saying here, don't remember the non-metallic characters. So metallic character down the group increases, then it will be decreases, isn't it? See the non-metallic character, what happened? Decreased here. Here also what happened? From here to here, what happened? Decreases here. Left to right also same thing actually. Reason, the electronegativity decreases down the group, whereas it increases left to right. What is the reason? If you observe what happened? So if you observe here what happened, fluorine to iodine, electronegativity decreases. When electronegativity decreases, tendency to gain electron will decreases. When tendency gaining of electron decreases, what happened? Non-metallic character also what? Decreases. But from lithium to what fluorine, what happened? Tendency to gaining of electron will increase because they are near to what actually? Octet configuration. So they will easily gain electron. Therefore, non-metallic character left to right in period what happened? Increases. Next, metalloids. These elements containing both metallic and non-metallic character. What are the examples? Arsenic, antimony, selenium, tellurium. They comes under these examples. These are the examples you have to remember actually. Metalloids. Non-metals are what? Tell me answer. Do first.
Sir, all of the
Sir, all the above.
All the above, right?
All the above, sir.
Now tell me the answer for this one.
Say increases.
Increases. Yeah, right.
Increases.
So this year, how many slides are there? Any number of slides are there, right? Okay. So this is only the topics we get in examination. Okay. Up to this, whatever we discuss now, we will get in examination, right? So in the next class, what we'll see here, periodic properties. Okay. So this is the second part of this chapter, periodic properties. So periodic properties will be discussed in the next class, tomorrow class. Okay. Tomorrow timings I will post on WhatsApp. You are having morning class tomorrow?
Yes, sir.
What time?
So 7 to 8.
Daily?
Yes, sir, ma'am takes it.
Actually, you're having English class timing, no? You have to, they're not following it. Okay, okay, no problem. You're having only 43 students are there. 17 members are absent today. After that, what they say actually, no. Sir, I was there at the class. You just post that message. See, if you observe what happened, you'll get everything here. If you have any doubts, you can stay with me. Otherwise, you can sign out. No problem.
Thank you, sir.
Thank you, sir.
Thank you, sir.